So let's get the meeting started with Arnold and the sky this month.
Well, thank you, Paul, and hello, everyone. I'm speaking to you from my home in Whitby, about an hour east of downtown Toronto. As I look up at the stars from my home, I do so in the traditional territory of the Mississaugas, a branch of the greater Anishinaabe Nation, which includes Algonquin, Ojibwe, Odawa, and Potawatomi. Here we go. Now, I'll be showing the sky as it appears from Toronto, and times will be for the Eastern time zone, which changes from daylight saving to standard time in just a few days. I'll be suggesting a number of targets in the southern sky and on the moon included in these 5 observing programs for beginner and intermediate level observers. Search RASC Observing to learn more and download the list of objects for each of these programs. Lists for deep space objects include their RA and DEC coordinates. Here are some highlights for the month. The moon comes close to 3 planets this month. 3 meteor showers will be peaking. Daylight savings ends this coming Sunday. There's a total lunar eclipse on the 8th. Later in the month, there is an opposition with Uranus, a night with multiple events with Jupiter's moons, and there's an excellent opportunity to watch Algol re-brighten from a minimum. The nighttime window is generous in November. Tonight, night starts at 7:45 p.m. and ends at 6:18 in the morning for a total of about 10 and a half hours of night. By the end of the month, night starts around 6:30, that's Eastern Standard Time, and lasts almost an hour longer by the end of the month. Astronomical twilight, when the sky is dark enough to view planets, that adds about a half hour before and after night. The beginning of November has the moon growing full and washing out deep space targets, with the full beaver or frost moon occurring on the 8th, when it glides through Earth's shadow. By the 3rd weekend in November, let's say the 19th, 20th, that's when the moon starts to become less of a problem as it becomes a new moon by the 23rd. When we do some slides coming up on deep sky observing, I'll be suggesting that we do it on the 19th because that's when the moon will be mostly out of the way. And when the month ends, it will be a first quarter moon. So now we will observe the sky facing south. And on the 3rd weekend, we can hunt for some deep space targets in 4 of the constellations that cross the meridian as night begins: Aquarius, Pegasus, Pisces, and Cetus. We'll start with 2 Messier objects. With the Sagittarius arm of the Milky Way nearby in the west, there are some globular clusters hovering over it, like M15 off the nose of Pegasus. It was discovered in 1746 by Jean-Dominique Maraldi and included in Charles Messier's catalog 18 years later. The globular cluster is around 12.5 billion years old and lies 35,700 light years away, yet it is so brilliant at magnitude 6.2 that it lies on the cusp of naked eye visibility from perfectly dark locations. M15 is one of the most densely packed globulars. Its center has undergone a core collapse and may have a central black hole. A 6-inch or larger telescope will resolve some of its halo stars. 13 degrees south of M15, or 4.5 degrees north of Beta Aquarii, lies globular cluster M2. It was also discovered by Maraldi in 1746 and is one of the largest known globular clusters. It lies even further than M15 at 55,000 light years, but is almost as bright as at magnitude 6.5. It is also one of the oldest of all globulars at 13 billion years old. In a telescope with sufficient magnification, you can resolve some of the oldest stars in the universe. Let's take a look at a couple of double stars. 3 Pegasi is a double star 3.5 degrees south-southwest of Epsilon Pegasi. The two components are magnitude 6.2 and 7.7, are separated by 39 arc seconds from our viewpoint, and both are on the main sequence. The stars are 285 light years away. The brighter component is a blue-white class A star. Our second double is 77 Piscium, found 3 degrees southeast of Epsilon Piscium. The term double applies perfectly to this pair. Both components are main sequence stars of classification F5, which makes them one class brighter and hotter than our Sun, and both are around 2 billion years old. They are true binaries with a 61-year orbital period. They lie about 8 light years from each other and about 140 light years from us. Turning to the finest NGC program, there's a very interesting galaxy found less than 1/2 degree northwest of a line connecting Delta and Omega Cetae. NGC 936 is a barred lenticular galaxy 50 to 60 million light years from our Sun. It has an angular size of 4.4 arc minutes. There are no spiral arms in lenticular galaxies, and this galaxy has very little new star formation. But we do see a ring of stars that connect to and are brightest at the ends of the bar. This gives the galaxy the appearance of a TIE fighter from the Star Wars movies and the nickname Darth Vader's Galaxy. Our other NGC target is 7009, the Saturn Nebula. You can find it 4.5 degrees east-southeast of Epsilon Aquarii. The planetary nebula was discovered by William Herschel in 1782 from Datchet, England. The nebula is an expanding shell of gas that leaves the core of the now dead star exposed. The core is 55,000 degrees Kelvin and is emitting strong ultraviolet radiation that excites the nebula to glow. Some may detect a greenish or yellow glow in modest telescopes. The nebula's distinctive Saturn-like appearance comes from its many halo jet-like streams and multiple shells of gas, giving the nebula a round appearance with two jets imitating Saturn's rings edge on. This nebula glows at magnitude 8. Its distance is not well known. It's anywhere from 2,000 to 4,000 light years away. There's a great opportunity on November 22nd to watch the eclipsing binary star Algol re-brighten from its minimum magnitude of 3.4, matching nearby Alpha Trianguli, up to its usual bright 2.08, matching nearby Gamma Andromedae. Perseus with Algol will be climbing up towards the zenith that night, so you will be looking through less and less atmosphere as it climbs higher, and the moon will be new. So conditions couldn't be better for making magnitude estimates with neighboring stars. When dimmer Algol B passes in front of A, the amount of light we see from Algol drops by a whopping 75%. That's easy to notice. But when B goes behind A, the dip is too small to notice visually. The stars are so close together, they orbit each other once every 2.7 days. Now here's a light curve of the drop in Algol's brightness. When B eclipses A, the light will drop from magnitude 2.04 down to 3.4 before rising up again. The dip when B goes behind A, shown here on the light curve, is just too small to notice visually. Now, if you head out on November the 22nd around 7 p.m., Algol will be in mid-eclipse, B in front of A, and its light at minimum. Compare it to Alpha Trianguli. After observing a deep space object, take another look at Algol. Is it now as bright as Rho Persei, the star next to Algol? Throughout the night, you can watch it match the brightness of neighboring stars as it climbs the scale. You can find comparison charts for Algol like this one online to help you. Now we turn our attention closer to home, the planets, starting with the inner solar system. Throughout November, while Earth is orbiting on one side of the sun, the innermost planets Mercury and Venus are hiding behind the other side. At the same time, Earth is nicely positioned next to Mars as we orbit up alongside it. By the end of November, Earth is only a week away from passing across the line that connects the Sun and Mars, which will bring us as close as we can get to the tiny planet on this orbit. Here we see Mercury and Venus emerging from behind the Sun as they head to the east throughout the month. By the end of November, they might be far enough east to be visible in the west after sunset. And this would be the view at the end of the month. Once the sun has gone down, wait for the sun to get below the horizon before you attempt this. Venus will be fairly bright at magnitude almost -4, and Mercury bright at -0.6, and they are both about 3 degrees above the horizon, so you will need a perfectly clear view to the west, maybe up on a balcony, or maybe where the ground drops off to the west so you have an unobstructed view to give this a try. Mars spends the month of November traveling in retrograde motion east to west between the horns of Taurus the Bull. Its magnitude will climb slightly from -1.1 to 1.4 by the end of the month. Its angular size will grow from a tiny 15.4 arc seconds to a slightly better 17.2. But the best feature is the fact that it's going to be up high in the sky. It's already 70 degrees up. It'll get to 71 degrees by the end of the month. And that's a big deal because the less atmosphere you look through, the more detail you're going to be able to observe from Mars. As I say, it's right now at altitude 70 degrees, so you're looking through just a little bit more than one atmosphere, 1.06. Now, you may remember that Mars had a really close opposition in 2003 when it was a generous 25 arc seconds wide. But at that time, we had to look through 2 atmospheres. It was only 30 degrees up because it was summertime when the ecliptic is low at night. But this time, Mars will be much higher. It'll be smaller, 17.2 arc seconds, but what we lose in angular size, we pick up in clarity, being higher up, less atmosphere, less air pollution, less light pollution, less turbulence to look through. Your chances of seeing some detail are better. And to help you see some details, you might want to use colored filters. Now, yellow and neodymium will provide contrast enhancements on any of the planets. But when it comes to Mars, you might want to try an orange one, and here's why. Here's a look at the albedo features without a filter, and they are a bit darker with the filter. You can even see the polar cap with this filter used. You're going to have to use a lot of magnification to see the detail on Mars. Here we see a simulated view with a 10-inch mirror, a rather powerful eyepiece at 5 millimeter, and even with a 2x power mate to boost the image up to this size, where you can start to see the albedo features such as Syrtis Major, seen here pointing upside down because it's a daub. Here's Syrtis Major, there's Hellas Basin, and there's the Arabia Terra, the large red patch behind Syrtis Major. 2 other albedo features are Sinus Meridiani and Argyre Planitia. And to help you see these dark features, you will want to give that orange filter a try. Now out to the outer solar system. Here we see the path of Earth during the month of November. You can see that it's crossing a line between the Sun and Uranus. We cross that line on November the 8th. Meanwhile, we are pulling away from Jupiter and Saturn and Neptune. So these will be getting, Jupiter and Saturn will become noticeably smaller during the month. And you can notice that it appears Jupiter and Neptune are on the same line of sight from Earth, so they should appear close together in the sky. You don't need any finder charts or help finding Jupiter. All you have to do is go out as soon as it's dark, face south, and it's the brightest point in the sky. As I was saying, we're pulling away from Jupiter, so its angular size will drop by a little over 8% during the month. Its magnitude drops a little bit as well. Its altitude at the meridian is a fairly good 44 degrees, about halfway up, so we're not looking through 2 atmospheres to see it, and that'll help us see some detail. And to help you see the details with Jupiter, give a blue filter a try. It will help highlight the contrast of its cloud belts and red spot, as noticed here. There the northern belt seems more contrasty, and the red spot pops out a little bit better. Now, I was mentioning that there are some very interesting events happening on the moon, with the moons of Jupiter on the 16th of November. Here we see Europa currently in transit. You can't see it when it's in front, but you will see it when it pops out into view. And its shadow will be approaching and crossing onto Jupiter just before Io pops into view from hiding behind Jupiter's shadow, and Ganymede will begin to transit. All of that's going to happen bang, bang, bang in real close sequence. So let's keep an eye on it now. Here we keep your eye here. Europa's shadow will be entering any moment now. There it is. Io pops into view. Ganymede begins to transit, and all of that takes place within 14 minutes. And by 11 o'clock at night, Europa pops back into view. So that's 4 events in 26 minutes. Not bad. Hopefully we have a clear night, and you can give this a try. Now, we are pulling away from Saturn. It's going to be shrinking by about not quite 5% during the month, as its magnitude also decreases. Its angular size for its globe and rings are shrinking, as you can see here between the 3rd and 30th. And there is no altitude at meridian because Saturn is already west of the meridian at nightfall. Observing Saturn, well, you're definitely going to want to use a Barlow to bump its size up. We're getting pretty close to the end of the observing season for Saturn, so give it a try while you can, because our next opportunity will have to wait until the summertime. And if you are giving it a try using a yellow filter. The faint cloud bands on Saturn are slightly more noticeable with a yellow filter. Uranus will be in opposition this month, and it is about 14 degrees southwest of the Pleiades, or to the right of the Pleiades if you're out around 9 o'clock on that 19th of November. Here I'm going to show you Uranus in a field of visible stars. So you should be able to see these stars without the help of binoculars, as well as Uranus, because it is at magnitude 5.7, brighter than the traditional cutoff we use of magnitude 6 for visibility. When you do see it in a pair of binoculars or a scope, you will notice that Uranus has a definitive round disk shape, unlike the star you see next to it there. That is a shapeless point of light that may also be flickering if there's turbulence in the atmosphere above us. Neptune, as we suspected, would be close to Jupiter in the night sky. It is found halfway between Jupiter and Phi Aquarii. In magnification, it too will represent a round disk. Here's the suggested view in binoculars, but I think you'll probably need a telescope to detect the disk shape of that very tiny spot. Now, much closer to home, up to the sun, I should say. Here we have videos of the sun that were taken earlier today by NASA's Solar Dynamics Observatory. On the left, we see the transfer of energy between the chromosphere and the sun's corona. On the right, the light of ion 9, that's iron without 8 of its usual 26 electrons. It shows the activity in the corona, such as magnetic loops and outflowing material. And here we see the currently numbered active regions with 3131 rotating away and 3135 aimed right at us, the most prominent of them. The number of sunspots are developing at a greater rate than what was predicted for this cycle 25. The chances for auroras go up with solar activity. Visit auroraforecast.com to get aurora predictions for the next 3 nights. Activity levels range from 5, which is moderate, to 7 or active, tonight, tomorrow night, and Friday night. On to the moon. Let's watch how the moon rocks and rolls this month. The northeastern limb of the moon tilts in our favor at the start of the month. There's an eclipse on the 8th. Apogee occurs on the 14th. Southwest librations occur after the last quarter. Perigee happens on the 26th of November, and the month ends with the moon a perfect first quarter. Maybe the top highlight of the month is a total eclipse of the moon, the last we will be able to see until 2025. You'll have to get up early and outside by 4 a.m. on Tuesday, November 8th to see it. The moon will be low in the west as it enters totality. For Toronto, the moon will be in twilight for the end of totality and will slip below the horizon during the partial phase of the eclipse. Because the moon will be low while totally eclipsed, photographers can incorporate a foreground scene to frame the blood red moon as dawn slowly illuminates the sky and foreground. Uranus will photobomb your picture. This is a great opportunity if the weather cooperates. Here are the 3 times the moon comes close to the planets this month. The moon is close to Jupiter in 2 nights, even closer to Mars 1 week later, and on the 28th, the moon is kind of close to Saturn, 6 degrees between them. If you are out observing the moon when close to Saturn on the 28th, you can study the moon for features in the Explore the Moon program. And here we see how the moon will look that night through SkyMaster 15 by 70 binoculars. The binocular version of ETM includes Mare Nectaris, the Sea of Nectar. This is the smallest of the moon's named mares at 350 kilometers wide. On the northern shoreline of Mare Nectaris is crater Theophilus in the telescope version of ETM. The Theophilus is a large crater, 100 kilometers wide and 3 kilometers deep. The crater overlaps crater Sirius to its southwest, which tells us Theophilus is younger. The crater has an imposing central mountain that reaches 1.4 kilometers high and features 4 peaks. The walls of the crater are terraced and show signs of landslip or avalanches. If you study this crater on November 28, you will see its central mountain peaks reach up into sunlight while the crater's floor is still in darkness. There are 3 meteor showers that peak in November. The first 2 are the south torids that peak on November 5 and the north torids a week later. Both the south and north torids don't have much of a peak, maybe 5 per hour. Both showers overlap and run to mid-November, so you might catch some on any clear night the next 2 weeks. When the south torids peak, the moon will be near and fat, washing out the fainter meteors. When the north torids peak a week later, a fat gibbous moon will be rising, again washing out faint streaks. Although the number of meteors may be low, there appears to be a 7-year frequency for fireballs, with one possibly occurring this year, and that would help. The south torid meteors come from debris shed by comet Encke, which has the shortest orbital period of known comets, only 3.3 years. It's believed comet Encke broke apart, producing a number of large asteroids, one being the source of the north torid meteors. The Leonid shower is the third to peak in November, this one on the morning of the 19th. The Leonids are debris from comet Tempel-Tuttle, which has a 33-year orbit. The shower is prolific, known for producing a high number of meteors. In fact, in the 1800s, there were 3 meteor storms that filled the sky with thousands of meteors an hour. In the Great Meteor Storm of 1833, also called the night the stars fell, more than 72,000 meteors an hour began raining down over the Americas after midnight on a moonless night. Imagine the spectacle with no moon or streetlights. The storm of 1833 launched a scientific inquiry into what causes meteor showers, eventually establishing the link between showers and comets. Today, we can use computers to model the paths of comets and their trails of debris and the gravitational effects the planets impose on both and make predictions. According to astronomer Mikhail Maslov, the 2022 shower could be impressive. He predicts activity can reach a maximum zenith hourly rate of 250 to 300 meteors compared to the usual 10, 15, or 20. He also predicts brightness will be much higher than the average level, maybe because the pieces will be larger. Because the radiant is in the east after midnight, it is in the direction where our orbit around the sun is taking us. We are plowing headfirst into the debris, so Leonid meteors impact our atmosphere at 72 kilometers a second, creating long and bright streaks. The moon won't rise until 2 a.m., and it will be a waning crescent, 23% illuminated. And we'll finish with a comet that is approaching us and beginning to grow a tail. It's comet C 2022 E3 ZTF. ZTF stands for Zwicky Transient Facility, located at the Palomar Observatory in California. They used a wide-field camera to survey the northern skies once every 2 nights. That's what they use, a wide-field camera to survey the sky every 2 nights, helping to find near-Earth asteroids that could pose a threat, and even they discover some distant supernovae. It's thanks to the Virtual Telescope project in Europe for capturing this image just 2 weeks ago. The comet is approaching us from the northwest above our orbital plane. It will come closest to the sun on January the 12th and closest to Earth only 3 weeks later at a distance of only 43 million kilometers. That's 1/3 of an AU, or 1/3 of the average Earth-Sun distance. And at that time, it will be seen fairly high north, 26 degrees from Polaris. Now, the comet is expected to become bright enough for easy spotting of binoculars as it passes close to the sun and approaches Earth. Optimistic predictions have it bright enough for you to see by eyes alone, and it's been a long time since we've had a naked eye comet. For November, you can catch the comet in telescopes in the west after sunset, cruising around a degree south of Delta Coronae Borealis. E3 is about magnitude 11. That was the measurement recorded back in late October, so it might be a little bit brighter now. I think you'll need about 8 inches of aperture to see the comet now, but hopefully it will be binocular visible real soon. The comet will become circumpolar in mid-January, so it can be seen all night. By then, will it have become a naked eye delight as it races through? And that's a wrap. Are there any questions?
Thank you very much, Arnold. Great presentation, and I really like those graphics that you used in your slides. Really, really well done. Emma, do we have any questions for Arnold?
Nope, we didn't get any questions tonight.
Oh, no questions. Okay.
Well, that's easy.
Yes, it was a very detailed presentation. Left no questions. Okay. Thanks again, Arnold. I appreciate the time. I know it takes a long time to prepare the presentations.
You're welcome, Paul. Thank you.